Again, welcome you formally because I just turn on the recording in Google Meet. So I formally welcome you to SCI33205, which is physics number 4. We need to start soon because we just wasted our time, 12 minutes already. We are here, right? The story about right-hand rule, right? I have shown you already the conventional effect, which is actually the Ampere's law. The Ampere's law will give you the information about how the signals, the magnetic field strength, okay, you get from this long straight copper wire. Okay, ผมอาจจะไม่ได้เปิดเสียงมากมายนะครับถ้ามีอะไรก็แจ้งมาได้เลยนะครับไม่ว่ามีนะครับหรือว่าทางใดก็ได้นะครับレスปอนส์มาทางที่ไลน์ก็ได้นะครับโอเคwhen we have a constant or uniform charge motion, right? We have a constant current. There will be electric field and magnetic fields, and there will be no electromagnetic wave yet, okay? Because there is no change or fluctuation of the velocity or the speed of the charge motion, okay? If the current changes, there will be electromagnetic wave. But in this scenario, which is the beginning step for us in the aspect of electromagnetic wave, there is no electromagnetic wave yet because it's a constant current here flowing in inside the copper wire. So there will be only two quantities, electric field and magnetic fields, okay? And one of the former, okay, not yet, we didn't go to BO1 yet. Well, here we consider this figure again, but instead of horizontal way, we are gonna consider something in vertical way, okay? When the long straight copper wire is oriented vertically like this, okay? You don't we just stick to the right hand rule, okay? We still use the right hand rule, and your thumb finger represent again the direction of the current, and the remaining 4 fingers will tell you the direction of the induced magnetic field, okay? But there is still no electromagnetic wave yet, even we align the long straight copper wire vertically like this, okay? And this is the first figure. Let's move to the second figure. If you consider the left side, okay, this is the cross-sectional view of this figure. This is the 3D view with your right hand. But this one is the cross-sectional view, okay? It's front cross-sectional view. If you study engineering, there are several sides in drawing. So this is one of the drawing sides, okay? If that you will need to learn or study the drawing subject if you study engineering, okay? It doesn't matter which branch are you going to go on, okay? Whether you study not only mechanical engineering, electrical engineering, industrial engineering, chemical engineering, all kinds of engineering needs to study drawing, okay? This is the front cross-sectional view, โอเคภาษาไทยก็คือภาพตัดด้านหน้าของเขานะครับโอเค on the left hand side, you can see that the magnetic field is going to point outward, okay, or outwards from the slide, but โปรดพิมพ์ชื่อนะครับพิมพ์ชื่อใน Google Meet นะครับเดี๋ยวผมจะได้รูดเก็บไว้นะครับขอรูดไว้ก่อนแล้วกันครับตอนนี้จบที่เริ่มที่ณภัทรนะครับณภัทร830ครับไปเลยแล้วก็ กิตติพันธ์นะครับทุวานนทานะครับขอเก็บไว้ก่อนนะครับเดี๋ยวอินเทอร์เน็ตล่มอะไรขึ้นมานะครับtest on the left hand side, the magnetic field is going to point out of the plane of the presentation or the slide or your monitor. Okay, this is the left hand side. It's denoted by the vector B and with the subscript OUT out. Okay, which means the magnetic field points out of the plane of the presentation on your monitor. Let's take a look at the right hand side of this figure, the second figure or the middle figure. Okay, on the left hand side, they just use the dot notation. Okay, in the rest of this story, we will use two notations. Okay, the first notation is dot. The second notation is the cross symbol here or the X symbol. You can say that. On the left hand side, we use dot to represent the front of the arrow. Okay, the front of the arrow. If you consider the vector, let me switch to the camera. Okay, if this one is the arrow and here is the head of the arrow, okay, we are going to use the dots to represent the head. Okay, if we look at the dots or the head or the face of the arrow, okay, we just see only the tiny circle, okay, which is the head of the arrow. Okay, and if we take a look at, okay, of course, this is the head, so this is the tail or the rear part of the arrow, right? And if we take a look by using our eyes, you can see that it's a tail. But sometimes they use some device to control, okay, the motion so that the arrow can move linearly, okay, in a linear way. So they use some device or to tie there in at the tail of this arrow. So that we are going to use the cross symbol or the X symbol to represent the rear. Okay, and that's it. So let's switch to our lecture notes. On the right hand side, you can see that the magnetic field is going to point into the plane of the lecture notes or into the plane of your monitor. So that's why we can see only the tail, okay, or the rear part of the arrow. So we use the X symbol or the cross side to represent the direction of the magnetic field. So this is quite important, which is the feature of physics. Okay, it's not mathematics, because in physics the direction is quite important, as I have mentioned to you in the previous lecture, or in any time of physics, even in your material 5 or material 4, the direction is quite important for us in the subject of physics. Okay, on the left side, we can see the head or the face of the arrow. On the right hand side, we can see only the tail or the rear part of the arrow, because the vector field of magnetic field is pointing into the screen of the monitor, and on the left hand side, the magnetic field is pointing out of the plane of the monitor. Okay, this is the front cross-sectional view of this figure. Okay, this is a 3D, this is the 2D version. And let's take a look at the right figure, which is again the 3D version of this one. But we don't care the humans' bodies anymore. We don't care the hand. Okay, we don't pay attention to the hand, the right hand. We just consider only what happens in three-dimensional view by paying attention to only the magnetic field. Okay, and you can see that when you use the right hand rule, the resulting direction of the magnetic field is going to turn around like this. Okay, around the long straight copper wire, but it's now arranged in vertical way. Okay, and if you take a look at the left hand side, left part here, what happens? What happens with YouTube? The steam current bit rates is lower than the recommended. I don't understand why. Good connection. Okay. This is the 3D view again, but with the view of only magnetic field. Okay, we don't care the hand of human. So if you stay at the left side of this long straight wire, you're gonna see that the magnetic field is pointing to you. Okay, out of the plane of your monitor, and that's why we get this notation, which is the symbol of the head or the face of the arrow. Okay, and if you are at the right hand side, this area, you're gonna see that the arrow of the magnetic field is pointing into the monitor. Okay, it's in this way. Okay, even you go farther from the long straight wire, you will get the same direction. Okay, because the magnetic field happened according to the right hand rule. Okay, and here is the text to explain all these figures. Okay, so now you would completely understand what happens with the steady state currents flowing into the long straight wire or the copper wire, right? Let's take a look at the let's take a look at on the next page. Okay, this is the formula. The formula of something. Okay, we have on the left hand side the variable b. Okay, which is it has some relation to this b. Okay, b here you can see that b is the magnetic field. Okay, b is the magnetic field, the vector, which is the vector quantity, and B on the next page in equation number 1, B, but without the arrow at the upper position, okay, because this is the magnitude, okay, magnitude of the magnetic field here, okay. Simply speaking, so now it's time to try to test the quality on the whiteboard. And, so it's already shown also in the slide, right? So I don't need to switch to the camera on the whiteboard. Sorry for that. Okay, let's get back to the presentation, to the lecture notes. Here, the variable B is the absolute value. Okay, the absolute value of the vector quantity B with the arrow above, or that. With the arrow above. This B is B here, okay, on this page, and that's a mathematics relation, but in human speech, it's magnitude, okay, magnitude of the magnetic field. Okay, this formula, this quantity is equal to mu 0. Okay, this is the variable mu, right? You may get familiar with this alphabet before. It's Greek alphabet. It's mu. Okay, mu with the subscription of 0 and I. Okay, the capital I represents the current. Okay, the steady state current. Okay, the current that flow in a constant velocity. Okay, constant amount per time. A or I. Okay, I is the amount there here in this figure, in all these three figures, or even in this figure, I is this quantity. Okay, I is the current. So current in this scenario is a scalar version. Okay, it's not a vector quantity. And what is mu 0? Mu 0 is 4 pi times 10 raises to the power of -7. Okay, it's magnetic permeability for the free space. Okay, if you stay in the deep space, okay, this is the value of magnetic permeability. And what is the meaning? The meaning of magnetic permeability is that the ability of a matter or substance that allow the magnetic field to be created in that matter, in that substance. Okay, if you let the magnetic field be induced in the water, for example, it may give you a different ability. Okay, different ability than the air or even the free space. Okay, that's the meaning for that. Another one is electric. So I forget the epsilon value. Okay, it's ability of a matter that allow electric field can be created. But this one is the ability of a substance that allow magnetic field to be induced. Okay, and the next thing is free space. Free space means if you are out of the Earth, okay, you are in the space, deep space, you get this value. But on Earth, we still also use this value for the situation when when it's vacuum, okay, there is no air, or we can also apply this value 4 pi times 10 with the power of minus 7. Okay, the magnetic field permeability of free space or vacuum. Okay, so the next this is the numerator position, right? The first position. Let's take a look at the denominator position. 2 pi, okay, nr. So there will be only two important variables. The first one is the current. Okay, the magnetic field depends on the current. Okay, if you insert stronger current, you will get stronger magnetic field. Okay, the magnitude of the magnetic field, or the absolute value of the magnetic field. Okay, and what is the variable? Variable is the distance you want to observe. Okay, let's get back to this figure. Okay, the figure number 3. If you stay closer to the copper wire, okay, the radius or the distance between the center of this copper wire and your position, okay, this is the radius, which is the variable r. If you stay closer to the copper wire, you get stronger magnetic field. Okay, that's the meaning. But if you stay farther from the magnetic, the copper wire or the conductor, you would get weaker magnetic field. Okay, if you go further and further or farther, okay, it's the case for you to have weaker magnetic field. Okay, when you get stay farther from the magnetic field, you get weaker magnetic field, and that's the basic realization of human. Okay, in two scientists who have observed these effects. Okay, it's the common sense. If you inject or you let the current flowing here stronger, okay, but with constant velocity, constant amount of motion, you get stronger magnetic field. Okay, in any position, if the current here is flowing stronger. But if you stay farther from the conductor, you get weaker magnetic field. And that's the common sense. Okay, two relations, and it's the basic idea. Okay? Right, as you study in the secondary school in Mathayom 1 or 2 or 3 or สุพรีวันนะครับเช็คชื่อมาทาง YouTube นะผมจะได้รูดไว้นะครับ copy as you have learned in the secondary school, okay, when you get when you have the relation or proportionality, right, there will be a constant. Okay, where is that? ขอเก็บชื่อแป๊บนึงนะ Where is that? Okay. พิสุทธิ์ด้วยโอเคจะได้เก็บไว้นะครับคราวที่แล้วเลเทนครับคราวที่แล้วได้ภาพจากคุณครูอัญชลีนะครับเป็นส่วนช่วยนะทำให้ผมลงคะแนนเข้าเรียนให้คุณได้ถูกต้องครับโอเคokay, let's go into our story but เมื่อกี้เน็ตล่มครับกสิทธิ์คนสุดท้ายที่ผมรูดไปเมื่อกี้เป็นกิตติพันธ์ใช่ป่ะทุนนทานนท์นะครับ หรือทุกวันนนก็ไม่รู้นะครับเป็นกลันเนาะสะกดบาลีสันสกฤตครับผมก็ไม่เก่ง so I need to keep your record okay let's get back to the whiteboard okay it's basic idea โอเคนี่ผมปูพื้นหน่อยครับเผื่อคุณอยากเป็นนักวิทยาศาสตร์ในอนาคตนะอาจจะเป็นอะไรบิโอสวัสดิ์2อะไรอย่างเงี้ยโอเค we just use the normal theory normal way in order to build up a relation and as you know ทุกคนเห็นครับผมย้ายมาที่whiteboard เพื่ออินเทอร์เน็ตมันค้างๆ so what happened should I stop something right ผมต้องหยุดอะไรสักอย่างเลยเพราะว่าเหมือนอินเทอร์เน็ตค้างๆนะครับAusgabe so is it possible be mine okay current stream is lower than recommendation so what next time okay so everybody can see me right everybody can see me otherwise I need to close something okay now we need to observe that okay you know that this is the long straight conductor right and you have the amount of current flowing in this way okay it's for some distance this is R right I hope that everybody can see it quite clearly if nothing wrong just raise your hand or let me know in any way maybe I write it too high this is the long straight copper wire right and we have here the current flowing in this way and here is the distance you are gonna observe okay and you are here okay and this is the radius the distance between you and the center of the copper wire and you would feel that okay you get one value if this is the current I1 okay and you get the magnetic field with this value okay with the subscript one but when you what happens is there any YouTube is not receiving enough video to maintain quality what happens the internet connection get quite low or what I don't know maybe that's the problem of internet connection here let me refresh okay okay this is the first amount in the same long straight wire long straight copper wire and you stay at the same position in again this is the same radius okay but now if you insert the current okay whose strength okay whose amount is greater than this one okay you here you get you can perceive the magnetic field as the second value be with subscript okay when I2 is greater than I1 and you can feel that the receiving magnetic field reduced magnetic field in the second scenario should be also greater than the first scenario here so it means with this relation we can see that B is linearly proportional to the current. Okay, this is the linear proportion, linearly proportional symbol, right? And that's the normal case. Okay, if you would like to be a scientist, in when you increase something, you increase the current and you get higher outcome, which is the magnetic field strength here. But you need to do this experiment for several values. Okay นะครับถ้า ผมสอนปีที่แล้วก็ไม่มีโอกาสได้ทำแลบเนาะก็เลยก็ไม่ทราบเหมือนกันนะครับว่าเขาจัดชั่วโมงให้คุณทำแลบได้บ้างเมื่อไหร่อะไรยังไง But during my age, in the material 1, material 2, or material 3, we have time to make experiments. So we make the experiment and observe if the output, which is the magnetic field strength, increases linearly with the currents, we can get this relation. Okay. Okay, and in the next aspect ไม่รู้ผมลงต่ำนี่คุณจะยังเห็นอยู่หรือเปล่านะครับนี่เห็นอยู่เนาะใช่ไหมครับ Otherwise let me get let me stick or make a pin to this one, okay, so that I can check whether what is the boundary you can see. Okay, fine. Everything is fine. Here, right. Okay. In the next aspect, if you have the long straight copper wire, again the same thing. Okay, and you just increase this. You just insert the currents with the amount I. Okay, with no subscription. Okay, we are going to use the same amounts of current flowing in the same long straight copper wire as well. Okay, this is the current flowing with the amount of I. Okay, the same value of current, and now we will observe the magnetic field in a different position. Okay, let's say this is the first position, which is quite close. Let's say it's R1. Okay, it's R1. You stay here at this position, okay, and you get the magnetic field with the value of B1. Okay, you stay quite close to the long straight conductor, and let's move a little bit farther from the long straight conductor here. Okay, we stay farther from the conductor with respect to this figure. Okay, this is the first scenario, this is the second scenario, and let's say this is the value of R2. Okay, R2 is greater than R1. Okay, let me write down here. R2 is greater than R1, and what we observe is the magnetic field strength, again the same variable B, but with the second amount, okay, the second value. And what we can feel is that when you stay far from the conductor, you see that you get weaker. Okay, you will absorb weaker magnetic field strength or even magnetic field. Okay, magnetic field strength would be the scalar quantity. Magnetic field would be vector quantity. Okay, and what we can feel is that the magnetic field strength in the second scenario, here is the first scenario. Oh, I'm sorry. The first scenario, and here is the second scenario. Again, here, when we make the experiment, this is the first scenario, and here is the second scenario. Don't get confused with the variable I, okay? I means the first, okay, in Roman numeric system. I with double bar here means the second, okay, the second thing, the second object in Roman numeric system, okay. This is the first scenario, the second scenario, and again in our second experiment, we have again two scenarios. Here is the first scenario, here is the second scenario, and in the second scenario we stay farther from the long straight copper wire the next week, but we keep we maintain the current value with the same fit and same amounts like this, okay. And what you will get when your radius is greater than before is that your B2 is less than the magnetic field in the first situation, okay, in the second, in the first scenario, okay. And with this relation, you can conclude by using the scientist's principle that B is inversely proportional to the distance, okay. I just list only two experiments here, the first scenario, the second scenario, but actually you should do it more, okay, with several values of radius R1, R2, R3, R4, R5, and you will see that when you stay farther from the conductor, you get weaker magnetic field strength, and finally you get this relation, okay, you get this relation, and after that may I have some space here, okay, and you will see thatต้องนี่มันก็ได้ครับเพื่อจะได้เห็นกระดานทั้งหมดครับ Not sure whether it's well functioning. It's all right. Okay. You can conclude that B, okay, depends on both currents and the radius, okay, the distance. So you would get something like this, okay. It's directly proportional to the currents, okay. You insert more current, you get stronger magnetic field. It's inversely, okay, proportional to the radius, the distance you observe, okay. And they just arrange something that's, if you take a look at this portion, it's actually the circumference, okay. The circumference ภาษาไทยเรียกว่าเส้นรอบรูปเนาะเส้นรอบรูปวงกลมนะครับ okay, circumference they just arrange something to this, okay, with this expression 2 pi r, okay. 2 pi r means the circumference of a circle, okay. You know that this is the circle, okay, and the amount you walk from any starting point, okay, you turn around this circle, you will see that the distance you have walked is circumference. I'm not sure whether you can see it, okay. Circumference is 2 pi r, right? This is the radius of R. Okay. You get this expression, and if you want to make this proportion to be equality, you need to do the experiment, right? And find the constant. Sorry for that. B is going to be K times 2 pi by R, right? Okay. And finally, they found that this value, the K value, is actually mu 0. Okay. Oh, sorry for that. My bad. It's I divided by 2 pi R. Okay. And K, okay, the constant of any proportionality. Okay, if you want to change the proportional sign to be equality sign, okay, you should have the constant, okay, according to the normal way in science. And finally, when K is calibrated from the experiment, and it becomes finally mu 0 in 2 pi r. Okay, and they found that this constant or the radius is equal to 4 pi times 10 with the power minus 7. Okay, and that's typical way for science. For typical way in science, okay, whether in chemistry or whether in physics and so on. Okay, in the persons who observe what I explained here on the whiteboard are two scientists. The first one is let's get back to our story in the on the presentation or the lecture notes. Okay, the first person who observed what I explained it to you is Biot, and the second person is Sawat. Okay, as I can remember, both are French scientists. นะครับสองคนนี้นะครับเป็นคนที่สังเกตอย่างที่ผมบอกบนกระดาษนะครับเนี่ยนะครับ so we will give the honor to these two scientists. We would say ผมอยู่ที่สไลด์แล้วนะครับ we would say it's B.O. Sawat's law. Okay, it's quite straightforward from the typical way in science in experiments and observation. Okay, when you want to observe the proportionality of something. Okay, let's take a look at the unit of anything, of some several amounts in this formula. It would be great if we make it bigger. Okay, mu 0 is a constant, right? It actually came from constant K, okay, in any science derivation. And okay, let's talk about the unit of magnetic field. Okay, B is magnetic field, and it's equal to volt seconds per square meter. Okay, ใครพิมพ์ชื่อมาท้ายๆครับก็กันตะพลเนาะกันตะพลครับเดี๋ยวเซฟไว้ให้นะครับกันตะพลin both YouTube and Meet, right? And also Meet, right? Okay. Stay. Okay. So what happened? Yes, sir. I'm live. The units of B, right, is volt second per square meter, but there will be a shorter name for that. Okay, this is the unit in SI system. Okay, second is the fundamental units in SI units. The second variable is mu zero. Mu zero is a constant, and okay. The short name of the volt second per square meter is T. Okay, is variable T, is the notation or the symbol T. T means Tesla. Okay, and we just give this honor to Nikola Tesla. Okay, he is from. I'm not sure he's from ใครทราบไหมครับเทสลามาจากประเทศอะไรผมลืมละเขาเป็นชาวเซอร์เบียเซอร์เบียมาจากเป็นชาวเซิร์ฟนะครับโอเค he's from Serbia and he moved to the United States and works with Thomas Alva Edison. We will talk about that in maybe in this subject in SCI33205 later. Okay. จะมีเรื่องของกระแสสลับเนาะกระแสสลับนะครับซึ่งน่าจะอยู่ในวิชานี้แหละนะครับเดี๋ยวมาว่ากันว่า Tesla ทำไมมีชื่อเสียงนะครับแล้วทุกวันนี้อารยธรรมของ Tesla ยังหลงเหลืออยู่ให้เราใช้อยู่ทุกวันนี้นะครับโอเคไหมเขาก็ถือว่าเป็นคนที่ปฏิวัติวงการไฟฟ้านะครับโดยเฉพาะอย่างยิ่งในอเมริกาจนทุกวันนี้นะครับหลงเหลือมาให้เราใช้นะครับคือกระแสสลับนะครับโอเคแล้วเราว่ากันในบทของเขานะครับwell, volt second per square meter is the SI unit, right? And it's not convenient for us. Okay, if we say all the time volt second per square meter, volt second per square meter, it's not convenient for us. So in the physics society, we just give the honor to Nikola Tesla, who would be the first person that deals with this quantity. So it's quite simpler to say Tesla, okay, instead of volt second per square meter. Right. The next thing is mu zero, which is the magnetic permeability, okay, the ability to allow magnetic field to be induced, okay, inside that substance. If you take a look at the unit of current, of course, you have ever seen that it's ampere, right? นะครับวิชานี้นะครับก็จะต้องการคุณสมบัติคุณนะที่ว่าน่าจะผ่านเรื่องราวของกระแสตรงมาบ้างนะครับก็คือว่าต้องรู้ว่าสักไฟฟ้าหน่วยโวลต์นะครับแล้วก็กระแสไฟฟ้าไม่ว่าจะสลับหรือตรงก็ตามนะครับหน่วยของมันก็คือแอมแปร์นะครับซึ่งแอมแปร์ก็มันจะมีหน่วย SI แต่เราไม่ค่อยนิยมพูดกันเขาจะใช้หน่วยแอมแปร์อย่างเดียวนะครับ100 milliampere, okay, is the surname of that person. So you can see that the unit of the current is ampere, right? And at the denominator is 2 pi has no unit, okay? The radius has the unit of in the SI system meter, okay? Has the unit of meter in the SI system. So if you move meter to the left hand side, it's going to be Tesla times meter, right? On the left hand side. And if you move I to the left hand side, it's going to appear as the denominator. You would get ampere at the denominator. So finally you see, or even you move 2 pi to the left hand side, it has no effect because 2 pi is unitless, okay? It has no units. So you will see that finally the unit of I should be Tesla times meter, which is the unit of radius, and divided by the unit of current, which is ampere. So finally, you can see that the unit of magnetic permeability is Tesla times meter by ampere, and that's the reason. โอเคพอเข้าใจนะครับถ้าไม่เข้าใจแจ้งผมจะเขียนบนกระดานดีไลท์ให้คุณดูอันนี้ดีไลท์กลางอากาศนะครับบนสไลด์นะครับ Okay, of course you know that I is the current and the unit for the current is the surname of Untitled milliampere, and I am sorry for that. Why small capital I and R นี่เป็นความผิดพลาดนะครับเดี๋ยวแก้ให้นะครับเดี๋ยวแปลงให้นะมันน่าจะเป็นผมไม่มั่นใจว่าเป็น R เล็กหรือ R ใหญ่แต่ว่าตัวอันเดียวกันนะครับอันนี้พิมพ์ผิดนะครับ R เล็กกับ R ใหญ่นะครับต้องเป็นอัน R เดียวกันนะครับเดี๋ยวแก้ให้แต่ว่าหลังจากนี้มันไม่มีแทนนะครับก็เลยไม่ซีเรียสนะครับเดี๋ยวแก้ให้นะครับหลังจากหมดเลคเชอร์ครับโอเค R is the distance, okay, the shortest distance you stay and you want to observe the magnetic field apart from the long straight copper wire. Okay, and that's the basic condition, right? We have uniform charge motion or movement, right? The current is in the steady state. Okay, the velocity of the current is constant. The amount of flowing charge is constant. The amount of current is constant. Okay, there is no change with respect to time. So there will be no electromagnetic wave. Okay, but we still have magnetic field or even electric field. But it's not our case, okay, because we are talking about the production of electromagnetic wave, okay, how the magnetic wave generates. Now we arrive at the second situation. When the charge changes their velocity, okay, and as you know, from the Newtonian motion, okay, or the motion according to Newton's law, when any object has the change of movement or velocity, there will be acceleration, right? Okay, when we have the change of velocity, it means we have acceleration. Okay, whether acceleration, which is the positive way, or deceleration, which is the negative way. Okay, we would say simply it's acceleration. Okay, when the charge changes their velocity, we have acceleration. When the accelerated charges take place in the conductor here or in the long straight copper wire, it's going to give us electric field, magnetic field, and also electromagnetic wave, okay, which is the main story for us in this chapter, okay, and as you can see, when there is a chain of acceleration, there will be three things, okay? First, electric field, okay, which still happens according to the case of when you have a positive charge and negative charge, there will be always electric field, okay? Because the charge is still moving, whether it has acceleration or not, we still get the magnetic field according to this figure. And the amount what you get would be something like this. But this formula is valid for only the a constant motion of charge. But when we have the acceleration of charge, we would get also electromagnetic wave, okay, the third quantity. So now let's take a look how the magnetic wave is induced. Okay, so at time, let's consider the time at 0 seconds. Okay, the starting time. What is this symbol? This is the symbol of the alternating current source. Okay, if not ผมได้ยินคุณไหมครับไม่ว่าทางใดก็ตามทางอัคควัตรซึ่งมานะครับอัคควัตรคุณแจ้งผมนะครับว่าไวท์บอร์ดเห็นชัดเจนดีไหมนะครับแล้วก็ผมจะถ้าไม่ดีนะครับผมจะลองย้ายไปเขียนที่Good Note ให้คุณนะครับใช่ไหมครับI'm not sure there is all right or not. Okay. Oh, that way, right? Okay. ทางไหนก็ได้นะครับทางนี้ก็ได้มานี้เดี๋ยวนะครับเก็บอัคควัตรให้ก่อนนะครับเพิ่งมานะครับนิดเขาว่าไม่ได้ผิดมาที่นี้นะครับand then okay let's okay that's it I'm not sure ถ้าผมขึ้น Good Note ที่ iPad นะมันจะไม่ออกที่ YouTube นะคนรับได้นะครับถ้าใช้ YouTube ที่บนกระดาษครับไม่ว่า Meet หรือว่า YouTube ก็จะมองเห็นนะครับโอเคso let me clean the whiteboard so that everything could be explained something can be explained because I also teach the subject of basic electrical engineering, so I would like to mention the difference between the current source, which is abbreviated or shortened by DC source, okay, and the second type of source is alternating current source เดี๋ยวภาษาไทยเรียกว่ากระแสไฟฟ้าสลับนะครับซึ่งคุณจะได้พบต่อไปแต่ว่าไหนๆก็ไหนๆแล้วใน lecture note เขาใช้สัญลักษณ์นี้นะผมจะได้ชี้แจงให้คุณทราบครับ It's better if I move it to menu นี่Okay. When we say let me remind you, this is the symbol of okay, everything is fine, right? This is the symbol of direct current source, okay, direct current source. DC ภาษาไทยเรียกว่าแรงจ่ายกระแสตรงนะครับCE okay and this is all right and the second type which is what we see here in the lecture notes is this okay with this symbol it's called alternating current okay or abbreviated by AC source so let's consider the functionality of two different types of voltage sources okay this is voltage sources นะครับแรงจ่ายแรงดัน okay this one this is the time oh sorry this is the voltage and it's denoted by V okay where the quantity variable V and here is time okay all denoted by variable T okay this is variable V and the same graphical illustration okay everything fine แจ้งได้เลยครับไม่ชัดไม่ดีครับอาจารย์ขอลองที่ Good Note เดี๋ยวผมจะ switch ไปที่ Good Note เขียนลองให้ก็ได้ okay and here is the time with variable T and here's voltage variable V okay and what happens with the direct current source is that it gives you all the time a value like this it's constant โอเคนะอย่างที่ผมบอกว่าคุณควรที่จะผ่านเรื่องของกระแสตรงมาบ้างครับ okay and here is the behavior of these voltage source let's say for example if it's denoted by 12 and V it's going to be the number 12 here on the y-axis okay and let's consider the second type which is our AC source it's going to be something like this okay it's sinusoidal waveform okay is that acceptable to you สำหรับคนที่อยู่บนนี้นะครับเดี๋ยวผมจะลองเขียนto have a problem of connection or something like that otherwise I need to quit or need to not use the internet connection from the Wi-Fi which takes the bandwidth of that thing so I need to plug it in using this internet connection ไม่รู้จะว่าเนื่องจากทีมหลักมีปัญหาครับผมออกจากไป Wi-Fi ของวันนี้ก่อนนะครับ I'm not sure whether it's Ethernet works or not let's try okay meet so right now I don't use the internet connection หลุดไปเลยthere's no M604 พอเปลี่ยนเน็ตแล้วหลุดเลยนะครับ okay let me get back to the meet okay no camera Thai name okay So I'm not sure whether the internet connection works well or not, but okay. Let me share the screen, right? Sometime meet. So what happened? It's feedback. So I need to practice one out. Okay. ถอดอันนั้นนะครับไม่ได้อยู่ดี so is there any way that I can use the internet โอ้สายนั้นอยู่ที่ห้องครับที่แบบอันนี้มันไม่ให้แชร์ครับno I don't want to ไม่แชร์ครับ okay no share at all โอเคเสียงไปครับแต่ว่าไม่แชร์เดี๋ยวจะลองเขียนgood note ให้คุณนะครับเพื่อเราให้คุณเปรียบเทียบครับแล้วคุณบอกว่าคุณชอบแบบไหนผมก็จะทำที่เหลืออยู่นะครับก็จะเลือกวิธีนั้นให้คุณโอเคthe screen view time travel yes sir ไปแล้วนะครับโอเคI'm sharing the noเอาพี่น้องOkay, I'm sharing the screen of the iPad by using some other internet connection. Okay, and so I'm trying to use the Google the Good Notes for you, right? Good Notes here. เพราะมันจะไม่ค่อย What is that? Was studierst du? Mathe, Physik. Is there any Physik? These. Okay, you can see. Okay, I'm trying to explain you again. We have here. อาจจะไม่เข้าข้องนะครับมือก็ได้ครับปากกาไม่ได้ใช้นานครับOkay here are the direct current source มาติดอีกนะครับ Okay oh my godไม่ได้เรื่องนะครับโอเคได้ breaks currents okay direct currents you have here the y-axis right which is the voltage and here is the time okay the variable t and here is the variable v okay direct current source is denoted by sorry for that how could I move เลื่อนขึ้นยังไงokay direct current source is the thing like this it use this symbol Okay, you just draw first the circle and positive side, positive polarity and negative polarity, right? And you connect it to somewhere else. the direct current source will give you the behavior of voltage as the constant value like this. Okay, and that's it. But for us in our lecture notes, it's no.เลื่อนนี่ครับนะ this is the current right เขาเปิดหน้าใหม่ยังไงครับเนี่ยอาจารย์ครับภาพใน YouTube มันกระตุกอะครับอ๋อแต่850แล้วใช่ไหมได้เลยสิครับผมถึงไม่อยากใช้อินเทอร์เน็ตเขาที่ถึงต้องมาใช้iPad ครับถึงใช้อินเทอร์เน็ตที่อื่นครับ so ขอโทษนะครับเพิ่งเห็นครับพิมพ์ในไลน์มาเนาะภาพกระตุกครับอาจารย์พิสุทธิ์ว่าตอนนี้ภาพใน YouTube โอเคไหมครับเขาก็แจ้งเตือนผมมานะว่ามันตอนนี้ผมไม่ได้ใช้เน็ตของYouTube is not receiving buffering ตอนนี้ผมไม่ได้ใช้เน็ตของเครื่องนี้นะครับที่ใช้สตรีมนะครับหมายถึงว่า iPad นะไม่ได้ใช้ไปใช้เน็ตแชร์ของเขาหลีกเลี่ยงมาใช้เน็ตอื่นครับเพื่อว่ามันจะได้ไม่ไปรบกวนครับแล้วจะได้กระตุกมากครับชนะนัดหมายถึงใน Meet หรือว่าใน YouTube ครับชนะนัดกระตุกมากครับนี่กระตุกมากครับหมายถึงใน YouTube เนาะคืออินเทอร์เน็ตเพิ่งกลับมานะครับคราวที่แล้วผมก็เซตค่าอย่างเงี้ยแล้วมันไม่เป็นไร YouTube ครับโอเคso what happens ตรงว่าใน YouTube โอเค let me use this only what is that 9,000 9 เมกผมลอง9 เมกตะกี้พิมพ์ผิดใส่เลข0เยอะไป90 เมกis that all right now in the YouTube ภาพใน YouTube โอเคไหมครับ I'm trying to draw something in the Google Meet, okay, by using iPad right now, because I want to let you compare the quality of vision, visibility in the Meet or the whiteboard. Let you compare the quality of whiteboard and the quality of good notes นะครับคุณตอบผมมานะคุณแจ้งผมด้วยนะครับว่าอันไหนดีนะผมก็จะได้ผมจะได้เลือกสิ่งที่ดีที่สุดให้คุณนะครับเดี๋ยวสั่ง iPad ใหม่นะครับอันนี้เขียนเลขเทสนี่ใช้มือเขียนครับปากกาไม่ได้ใช้นานผมลืมไปแล้วว่ามันเปิดยังไงโอเคnow ตอนนี้ผมอยู่ที่ Meet นะครับผมอยู่ที่ Meet แล้วก็จะลองเขียน Good Note ให้คุณดูนะครับเหมือนที่ห้อง605เรียกร้องนะครับโอเค now let me make a new one okay now we cause theไม่ติดor should I Bluetooth เขาต่อไงว่าใช้ได้เลยไม่ต้องต่อนี่ก็ได้โอเคthe good notes right no มือ มืออีกครั้งครับ now we consider the alternating current alternating current โอเคคือใช้มือแล้วมันคุมไม่ค่อยได้ครับไม่เหมือนปากกาครับ okay alternating current chain again we have the ต้อง2 นิ้ว we have the plots of the voltage and the time. Okay, this is variable t and here is v. And the symbol for the voltage source or even the current source, okay, is written like this. You draw first the circle and the tube side, okay, and you can connect it to any other components in the circuit, okay. อันนี้พูดถึงว่าถ้าต่อในวงจรนะครับ you draw a circle and you have the tube at the center of the circle, and just that it's only one period of the pulse, and the line above and the line lower is the possible connection to other devices in the circuit. Okay, with this device,ตอนนี้ YouTube คุณภาพเป็นไงไหมครับ Stream current bit rate is 4589 is lower than recommend bit rate. We recommend you stream bit rate of 5000. Okay, our moment. Now let me change. ผมจะเลือกเป็น 4,500 นะครับตามที่ YouTube บอกกันนะ45 kbps ตอนนี้ YouTube กระตุกอยู่ไหมครับเปลี่ยนเป็น 4,500 ตามที่ YouTube เขาแนะนำมาแล้วนะครับไปแล้วนะครับไม่ขึ้นโชว์ละถ้ามีอะไรแจ้งทันทีครับตะกี้พี่มาทางไลน์แล้วผมมันตัวหนังสือไม่ได้เตือนนะวันหลังโทรมาเลยที่ไลน์โอเค now let's get back to the good notes the behavior of the AC voltage source is the following. It would give you the voltage behavior like this. Okay, it's sinusoid waveform like this. Okay, so that's the voltage. Okay, that fluctuates. Oh, sorry for that. My God. ผมก็เลยกำลังซูมออกOkay, that's the behavior of the voltage source. Okay, when the source is voltage AC, okay, alternating current voltage source, it will behave like this. Okay, the voltage varies with time. Okay, and that's the meaning of this symbol. The circle and with the tube at the center of the source. Okay, it's called AC source or alternating current source, which is voltage source in this scenario. Okay, now so now we finished not the whole class. I finished the presentation in the Google Notes and just let you compare it. So again, the recommend bit rate is yes, I'm using for 5,000 kbps. Video. I can't say anything right now. No. And that's Okay. Now let's get back to stop. Stop the screen sharing, right? ตอนนี้ YouTube หรือว่า Meet ก็ได้นะครับ now we move to the lecture notes and here okay you understand now you understand the symbol of alternating current source, right? จะอยู่ YouTube หรือ Meet ก็ได้นะครับเหมือนกันครับตอนนี้ you understand the symbol of this thing, right? The AC voltage source, okay? And as you know, the voltage changes with time. And here is the line that I have mentioned. You can connect it to any other components in the circuits, okay? But we will take a close look only at the voltage source, okay? One side of voltage source can be positive and another side can be negative. Let's say, for example, at the starting time, at time of 0 second, we have positive, okay? We have positive side here, which means the electrons, okay? A large number of electrons have moved to this side, okay? When electrons move to this side, the number of electron is the number of negative charges is greater than the number of positive charges here at this side, and that's why the prominent or the dominant charge at this side is going to be negative. Okay, so in this part, negative or the electrons have moved away already. The prominent charge will be positive charge, or the dominant side. The dominant charge at this side is going to be positive charge, okay? And that's why we see this symbol. Okay, this is the starting time, and when the time goes, let's take a look at the figure B. For example, this is capital T by 4, which is 1/4 of the period. Okay, 1/4 ของข้ามนะครับ okay ไหม here before that this is the starting time, right? We have strongly positive at this side, and that's why the curve or the electric field is positive, maximally positive at this side, but it's not the time right now. The time right now, the electric field decreases, okay? And at time as period by 4 or 1/4 of the period, the electric field decreases to be 0 here, okay? And you can see the tendency of decreasing amount of electric field, okay? At the starting time, this side is strongly positive, and that's why we have the positive curve of this the blue line here. But at time T by 4, the electric field decreases, okay, and reaches 0 at this point. Now let's พอเข้าใจนะครับจาก A มา B นะครับ so now we consider the third figure, which is figure C. Now we arrive at the time of period by 2, which is half period. Okay, เดี๋ยวบอกว่าคาบคืออะไรนะครับเห็นไหมคาบเป็นคำนามนะครับไม่ใช่คำกริยาที่หมายถึงเอาปากงับอะไรไว้นะครับหมายถึงว่าเป็นคำนามนะครับคำว่าคาบนะครับ period ครับ Okay, here at the starting time, we have a strong positive at this side, right? The lower side is strongly positive. It's dominated by the positive charges. Okay, this is the time, the starting time. Okay, time at 0, and here is the time at period by 4 or 1/4 of period. There is no dominant side. There is no positive dominant side or negative dominant side. Okay, both sides are neutral. Okay, without dominant charge. Okay, at both sides. But this one in this figure here is the time at period by 4, which is quarter, right? And as you know, because we have the sinusoidal AC source, as I have mentioned earlier, the curve of sinusoid will decrease like this, okay, until it start to get a negative value, okay, or minus quantities, something like that. Okay, the electric field start to get negative value, and it somehow this, right? And here you can see all the time here the electric field is negative. What is the meaning of negative? The negative means we consider the lower parts, okay, the lower rod or the lower side of this figure, right? And this figure, there is no dominant charge, that's why it's 0. But when this one is negative, it means this part will be dominated by negative charge, and that's why you see the symbol of negative signs here. Okay, it means electrons move from that rod, move from that side to this side. Okay, and a large number of electrons are at this area, so that's why we get this curve. Okay, and at periods by 2 or half period, we get the maximum negative amount of charge. Okay, and that's why we have the maximal negative level here of this curve. Okay,พอเข้าใจนะครับเนื่องจากแรงจ่ายมันเป็นสัญญาณสลับนะครับเราดูข้างล่างเป็นหลักนะครับข้างล่างมันบวกใช่ไหมครับบวกก็เวกเตอร์ชี้ขึ้นข้างบนบวกสูงๆเนี่ยนะครับพอเวลาผ่านไปเรื่อยๆความบวกมันน้อยลงหมายความว่าอิเล็กตรอนมันเริ่มจากที่มันเยอะอยู่ตรงนี้นะครับมันค่อยๆถ่ายโอนมาฝั่งนี้นะครับเห็นไหมถ่ายโอนวิ่งไหลมาฝั่งนี้นะครับเนื่องจากซอร์สเนี่ยมันบังคับให้อิเล็กตรอนไหลมานะครับพอเวลาผ่านไปเรื่อยๆนะครับคาบส่วน c นะครับหรือว่า1/4นะภาษาอังกฤษนะครับอิเล็กตรอนจากที่มันอยู่หลอดข้างบนนะครับฟากข้างบนซีข้างบนนะครับมันไหลจนมันเป็นกลางแล้วมันไม่ไปซีนี้แล้วมันก็มาสมทบจากที่มันบวกเด่นๆอยู่ตรงนี้นะครับกลายเป็นกลางครับพอเป็นกลางก็หมายความว่ามีความเป็นกลางทางไฟฟ้านะครับสนามไฟฟ้าเป็นศูนย์ครับหน้าที่เวลาคาบส่วน 4นะครับหรือว่า1/4ในภาษาอังกฤษครับแล้วพอผ่านไปเรื่อยๆครับเนื่องจากแรงจ่ายเป็นแรงจ่ายไซนูซอยด์คุณเห็นซิมโบลสัญลักษณ์ของมันขึ้นลงอย่างนี้นะครับขึ้นภูเขาแล้วก็เหวสลับเงี้ยนะครับมันบังคับนะครับให้อิเล็กตรอนเนี่ยวิ่งไปตามที่มันต้องการนะครับเมื่ออิเล็กตรอนนะครับไหลจากข้างบนลงมาข้างล่างมานะครับตรงนี้ก็จะมาหนักเข้าไปใหญ่เลยนะพอตรงนี้อิเล็กตรอนขาดหายนะครับเนื่องจากซอสมันบังคับนะครับแรงจ่ายบังคับอิเล็กตรอนวิ่งมาตรงนี้ก็จะเด่นประจุลบไปนะครับโอเคไหมตรงนี้ถูกดึงอิเล็กตรอนมามันไม่มีอิเล็กตรอนมันก็เด่นเป็นบวกครับเพราะว่าในนิวเคลียสของอะตอมมันมีโปรตอนอยู่ใช่ไหมครับแต่ที่เกิดเหตุการณ์นี้นะครับมันเกิดที่เวลาคาบส่วน2 capital T by 2 okay so let's go further
อาจารย์ครับตอนนี้10:10อาจารย์
ครับหมดเวลาใช่ไหมครับหรือว่าไงครับอาจารย์ครับภาพใน YouTube มันกระตุกพูดเมื่อ9:50 What happens is there any
หมดเวลาแล้วอาจารย์
หมดเวลาใช่ไหมครับ Okay I'm sorry for that so is there anybody who did not write down your name I'm going to close the lecture right now so we need to finish our lecture so see you on Wednesday I hope that there will be no problem or internet connection again สวัสดีครับบ๊ายบายครับ so I need to stop recording stop recording in Meet stop recording